So you are looking for the vegetable peeler. The desire to peel a cucumber is most likely functioning as A, CMOR, B, CMOS, C, CMO-T, or D, UMO. So B is the correct answer here, CMO-T. Here's why. A CMO-T makes something else effective as a reinforcement. So this is an example with finding your phone, but you could put peeler in here too. You wanting to eat peeled cucumber is the thing that makes finding the peeler effective as a reinforcement. So there's a CMO-T. And then with a CMO-T, there's almost always a CMO-R, which is the skin of the cucumber is essentially making its own removal effective as reinforcement. So there's a CMO-R with every CMO-T. So we want to peel the skin off of the cucumber. And so we need to find the peeler to be able to do that. And then the response of looking for the peeler is increased because we want to find the peeler. All right, let's try another one of these. We're going to stop sharing this one. We're going to relaunch the poll because this is one that is tough for people a lot of time. Which one of these is most likely to be a CMOS? A, asking a neighbor where they got their cute holiday decorations. B, losing your purse at work. C, seeing the branding on the bag of your favorite kind of popcorn. Or D, having an itchy feeling on your back. This one. So we'll end this poll. We'll share the results. So 75% of you said C, 25% of you said B. So 75% of you are correct. C is the correct answer here. Seeing the branding on the bag of your favorite kind of popcorn. And I'll explain why this becomes a CMOS. So in the book, they gave us the example of water deprivation. So that's a UMO. We come built in with that. If we're deprived of water, water is going to be more effective as a reinforcer. So we have this value altering effect of establishing water as a reinforcer, and then a behavior altering effect of increasing all behaviors previously reinforced by water. This exists at birth. And this is true for us with food too. So we could say food deprivation establishes food as a reinforcer. So value altering effect of establishing food as a reinforcer. And that also has a behavior altering effect of increasing all behavior that's been previously reinforced by food. So in this case, we've paired food deprivation with our favorite bag of popcorn. Yes, our favorite bag of popcorn. So over time, when we're deprived of food, we also come in contact with this branding, which is to get to the food that we like to eat, right? So we see the branding on the bag as we go to eat the food. And so over time, these are paired together. So eventually, just the branding of the bag of popcorn establishes food as a reinforcer and increases all behavior previously reinforced by food, which then makes the branding of popcorn a CMOS for food deprivation. So this is why this is a CMOS. This is also why, I don't know if I say this like overtly in the pre-recorded lecture, but this is also why we have like a serious nutrition problem in this country, because we have really great branding on foods, but like this is telling us that this is how our brain works, is that if we pair certain branding with being hungry over time, then eventually just that branding will evoke food being a reinforcer and increase all behavior previously reinforced by food, regardless of how hungry we are. So it means we may reach for popcorn, chips, whatever, even when we're not that hungry. It's the thing of like when you're driving down the interstate and you see like McDonald's or whatever fast food sign, eventually the sign over the course of your lifetime has probably been paired with food ingestion a lot of the time. And so that sign over time becomes a CMOS for the UMO of hunger, which means you see the sign and you're like, food would be really great now, even though you're not that hungry. And the behavior of pulling over, going to the drive-through are all increased because in the past, those have been connected with that. So it is just a CMOS. The easiest way to remember this is it's a surrogate. It's a stand-in. It is literally just taking the place of. That's why this visual is helpful for me. So unlike T, CMO-T, where it's transitive, it makes something completely different effective as a reinforcer. A CMOS, it makes a stand-in for itself effective as a reinforcer. Make sense? And a CMOS is almost always going to be for a UMO. Could be for CMO, but most of the examples that you're going to get are going to be a UMO. I would say a good example of something that may be different for this is like, let's say your bank's branding, right? So if over time you had, we'll go back a page, needing money has been paired with establishing stopping at the bank as a reinforcer and increasing all behaviors that previously led to you having cash in your hands. And then if over time the CMO of stopping or of having need, I guess the CMO needing money or needing cash was paired with the neutral stimulus of your bank's branding, then eventually your bank's branding could then essentially alter the value of having cash as a reinforcer and increase behaviors that have been like pulling over going into the bank to get cash. And then we would say that the bank's branding is a CMOS for a CMO of needing cash. Another. All right. We're going to stop sharing this one. We're going to relaunch the poll. So you race home to see if your teenage child got home from soccer practice, but notice their car isn't in the driveway. For seeing your child, the driveway being empty is most likely A, discriminative stimulus, B, a stimulus delta, C, an establishing operation, or D, an abolishing operation. We're going to end this poll, share the results. So 50% of you said A and 50% of you said B. So great job identifying that this is not, we're not talking about establishing or abolishing operations here. No motivating operations at play. We're talking about whether or not this is a discriminative stimulus or a stimulus delta. We're talking about stimulus control here. So the correct answer is that the driveway being empty is a stimulus delta, which lets you know that reinforcement in the form of seeing your child is not available because your child's not home, right? So let's back up and see what this looks like. A stimulus delta is that in the presence of this stimulus, reinforcement is not delivered or lesser quality of reinforcement is delivered. So in our case, this is an example of a stimulus delta. If there's no pie on the table and we ask for pie, then no pie is going to be presented. So it's like, I can want to see my kid, but if their car is not in the driveway, then me going inside and being like, hey, kid, no kid's going to be presented because they're not home. Their car's not in the driveway. So when I've done this in the past, when I've come in and been like, hey, kid, when their driveway is empty, then I've done that less in the future because no one answered. The kid didn't show up. So this becomes a stimulus delta for accessing the kid. Does this make sense? So this is where we get into that chapter 17 when we talk about stimulus control. So stimulus control is talking about discriminative stimuli and stimulus delta. A discriminative stimulus tells us it's available. So it's not whether we want it. It has nothing to do with whether you want to see your kid. It just says your kid is not available. Their car's not here. So if their car is in the driveway, their car's not here, they're not available as reinforcement. So they are a stimulus delta, not a discriminative stimulus. If their car was in the driveway, that might be a discriminative stimulus. In the past, it might have been paired with then the response of saying, hey, kid, and the kid being there. Make sense? All right, we're going to try one more of these. Oh, I threw in this too. So discriminative stimulus is a stimulus that signals the availability of reinforcement. So I think all of you got that it was about available, not want for motivating operation. So it wasn't whether we care about it. It wasn't whether it's effective as a reinforcer. It's whether it's available as a reinforcer. When it's available, we're talking about discriminative stimuli or stimulus delta. So this is a stimulus that signals the availability of reinforcement. So reinforcement is delivered in the presence of the stimulus and not delivered in the absence of the stimulus. So a discriminative stimulus example would be seeing pie on the table, asking for pie, receiving pie. So in our example of the driveway, it would be seeing the kid's car in the driveway, then coming in and saying, hey, kid, and then the kid is there. So seeing their car in the drive or yelling for your kid when you see their car in the driveway would probably increase in the future. And then eventually this would become a discriminative stimulus. All right. The opposition to that is motivating operations. Remember, it increases the effectiveness of a reinforcer or decreases the effectiveness of a reinforcer. All right, last one. A discriminated operant is less affected by motivating operations and equally likely to occur under certain antecedent conditions. B is less affected by motivating operations and more likely to occur under certain antecedent conditions. Or C is equally affected by motivating operations and equally likely to occur under certain antecedent conditions. or D is equally affected by motivating operations and more likely to occur under certain antecedent conditions. All right, so we're going to end this poll. We're going to share the results. So an equal spread here. We had 33% of people say B, 33% of people say C, and 33% of people say D. Now, this is one of those tricky concept ones because the question's actually asking you two different parts of the concept. So discriminated operant, we don't even know what it's asking us. And then when we read through the answers, we essentially see two parts, which is it less affected by motivating operations or equally affected by motivating operations? And is it equally likely to occur under certain antecedent conditions or more likely to occur under certain antecedent conditions? So the correct answer here is D, is equally affected by motivating operations and is more likely to occur under certain antecedent conditions. So to answer this, we have to know what a discriminated operant is. So a discriminated operant is a behavior that occurs more under some antecedent conditions than it does in others. It occurs more in the presence of a discriminative stimulus and less in the presence of a stimulus delta. So a discriminated operant is the response. So it's essentially the response that follows a discriminative stimulus or a stimulus delta. So in our SD example, seeing pie on the table lets us know that pie is available. We ask for pie because in the past, asking for pie when there was pie on the table made it where we actually received pie. So asking for pie when there's pie on the table increases in the future, and eventually this can become a discriminative stimulus. And when this becomes a discriminative stimulus, this becomes a discriminated operant, which means it occurs more under some conditions than it does in others. But the first part of the question asks us, is it less affected by motivating operations or equally affected by motivating operations? And a discriminated operant is equally affected by motivating operation. Even if, so a pie example is a great example. This is a discriminated operant, but if I don't want pie, I'm still not going to do it. And if I'm really hungry, I'm still going to do it way more, right? So what the establishing operation of being hungry or the abolishing operation of just eating a bunch of pie are still going to affect a discriminated operant similarly to the way that they would any other behavior. Motivating operations don't have special rules for discriminated operants. Discriminated operants fall under the same rules about motivating operations as any other behavior does.